Hey, it's David Palmer. I hope you're doing well. Hey, we're going to talk about some urban geography tonight, and we're going to talk a little bit about baseball. It is baseball season. We're going to talk a little bit about transportation, but you know what we're not going to talk about? Justin Bieber. So let's get going on this journey. So let's get this urban geography journey on its way. So urban geography can be broken down into three big parts, typically how I teach it. We've got part one, which is this video is mostly going to deal with, which talks about systems and distribution, basically where cities are, why they're there, how they're spread out, and the factors that influence that. Part two of this unit usually deals with the structure and the land use within a city. These are the land use models of North American cities, Latin American cities, things like that. And then part three deals with the impacts, the effects, the future. What are the future trends going on and the impacts of cities on the environment and both the pros and cons. So those are the big three parts that we'll focus on, but this video mostly is part one. I do want to thank, before I get going, Dr. Phil Klein at the University of Northern Colorado, who many of these slides he helped create and helped me to inspire to become a better geographer. So thank you, Dr. Klein. So, urban hierarchy. This is this idea of a system of cities, and there's various levels. There's very few cities at the top. So this is the Colorado cities, and there's Denver is way up here. And what we have on this graph is we have population on this side and number of types of businesses on this side. Higher order cities have more businesses and more people, or maybe the other way around, more people first, and then that results in more businesses. And so this pattern exists. Now this is in 1899, but this pattern still exists today. And we have all kinds of small towns that have a few businesses, but there's a lot of small towns that are listed here. So when we see this pattern exists at the regional, national, and global scale. And the fact is that cities, their main purpose is to provide services. And they provide more services than small town. And this is called urban hierarchy. So this map, you've seen the Earth at night before. This is 2000. We'll look at a newer one here later in this video. But what we're going to try to make sense of is this distribution of how cities are spread out. They're not evenly distributed. They're spread out, and we're going to talk a little bit about why they're spread out. We have the agglomeration of the megapolis in the east, but then we have this distribution of cities, and there's some theories that help explain why this occurs, and we're going to spend some time with that. So this is the ranking of census MSAs. Now what an MSA is, a metropolitan statistical area, and it's basically made up of multiple cities. So you have towns and cities, and then you have MSAs or metro areas. And so like the New York MSA is made up of New York, Northern New Jersey, Long Island, and these all group together to form in 2005 about almost 20 million people here. And then when we look down here, we have LA, Long Beach, and Santa Ana. They constitute around 12 million, and Chicago and Joliet and Naperville are about 9 to 10 million. Now, roughly when we look at this, we also want to notice that there's one large city and then roughly two cities that are about half the size. And then as you go down, there's more cities that are a third of the size and even more cities that are a fourth of the size. And you can see this pattern as it exists right down here on the left. There are more cities that are smaller than these very large cities like New York. And this pattern is a very important pattern for you to understand. Now, here's some more updated data. This is 2016 as well as 2010 data. And I already explained the city versus metro area and MSA, but make sure you understand that as going forward. Now, we want to look at pattern of city size in terms of population. We're not talking spatial area in terms of how big and spatial area. We're talking about, in this case, number of people. And so you want to look at that and understand the patterns and looking at the numbers based on, this is United States numbers, and once again we see 20 million and then roughly two cities that are not perfectly half, but about half, and then a few more that are a third of the size. So that same pattern has continued. We call that RankSize Rule, which I'll discuss here in a moment. But I also want you to make note of this column over here. On this column, it's talking about percentage change. You're going to need to be aware of what parts of the world are growing and which parts of the world are shrinking in terms of population. Now, very few places of population are shrinking, but regions within a country might. So these are cities that are growing. So Houston is in Texas, and this is showing a population growth of people migrating to Texas, of Houston, Texas, of 14%, which is huge growth. Right above that is Dallas, Texas. Dallas has a population growth of about 12%. So these areas are increasing rapidly. Midwestern cities like Chicago are staying about the same. And you want to pay attention to the patterns. In general, as you learned in the population unit, cities and areas in the southern United States are growing, as well as cities in the west, like Denver, Seattle. These areas are also growing in terms of population. Midwest cities and northern cities tend to be stagnant or maybe slightly declining. So those are patterns that you definitely need to be aware of, both for this unit, but also for your population unit. Rank size rule. Rank size rule is the basic concept that the second largest city, the nth largest, so if it's the second largest city, will be about half the size, and the third largest city will be about the third of the size, and the fourth, and you don't. It's not absolute. It's just in general, half, a third, a fourth, a fifth as you go down, and you can see the linear pattern here that shows in the United States. If it follows a primate city model, which I'll talk about here in a moment, it drops off dramatically. Now, if the drop off is here and then it turns into this pattern, it's still a primate city model and does not fit rank size. This is the typical rank size graph that we would see, this nice linear curve going down. Okay, the US is a good example of a rank size rule, by the way, but you do need to look at the data, and when you apply that data, make sure you understand how it's done. So review your books related to that. Primate cities. Primate city is when you have one dominant city. It's by far the most powerful, both in size as well as power within the city, and it's more than twice the size of the next largest city. And I've mentioned this before, but when you think of France, I mean, almost everybody thinks of France, of Paris, all right, as being the dominant city. The next largest city in France is Marseille at about 1.2 million, which is much smaller than Paris. So be aware of that pattern. This is called a primate city. There's some other countries of the world or cities that have primate city. Can you think of any? Well, Mexico City is a good example. Mexico City is a primate city. Over 20 million people, and the next largest city is like 6 to 7 million. United Kingdom has a primate city. What city would that be? That would be London. Yeah, that'd be London. So that's a primate city. Now, also, oftentimes primate cities, those countries tend to be unitary, as I've explained before, but not always, but that's a pretty strong pattern. So be aware of that, and that relates back to political geography. Now, site and situation. Site and situation is a concept that crosses across units. You learned about it in Unit 1, in Chapter 1 probably of your books. It has relevance in economic geography. It also has relevance in urban geography, and also site and situation has relevance in agricultural geography. So really critical concept and must be understood across all units. So site is the characteristic at the immediate location of whatever you're talking about. In this case, we're talking about a city. So what are the things that are right around the city? What type of soil, the climate, is there a labor force? Is there a harbor? Is there rivers, mountains, hills? What's there? Okay. Situation relates to the location of a place relative to its surroundings, but it speaks more to its connections and its accessibility and the interactions and the proximity to maybe resources or markets and things like that. So it has more to do with connectivity and the connections with other places. Okay. Super important concepts. Make sure you understand it has relevance across multiple units. Now, we're talking about cities, and so what I want you to do is, this is a little activity. If you're one of my students, this is on Schoology. If you want to download it, you can do that. If not, you can just look at it here. These are early settlements, and we have a series of ideas here. We have river meander site, and then you have to locate and identify which of these is a river meander site. I'll help you out with this first one, because a river meander site, this is the river. It's meandering means it's bending around. And this is the city right here. So this would be, the answer would be I. Now, is this for defense or trade? Well, this is a wall indicate. So I could see here being beneficial for defense because you're protected by the river. You've got a wall right here. You can easily defend this one spot. But there's also some benefits of being on the river, so that's good for trade. So what I'd like you to do is I would like you to attempt to do this activity by looking at this and trying to match them up. So take a few minutes, pause the video, and take a minute to do that. Okay, so how'd you do? Let's take a look at this. Here's the answers to this. I already did this first one with your meandering site. Acropolis, this one's a little hard to see on the graphic, but this is a hill, so it's not a very good hill, but it's a hill, and this is the city. This would be like Athens, Greece. This is primarily for defense. Being up on a hill is primarily for defense. Head of navigation is down here at J. What this means is head of navigation is where a river becomes navigable, where it's wide enough that you can put a boat in there. That's what that's referring to. Portage site, H, right here. This is where two bodies of water come in and you have to maybe carry it across from one body of water to another. In this case, I'm showing rivers, but it could be lakes also. That's oftentimes the case. Like Buffalo, New York would be a good example of that. Offshore island site, probably one of the easier ones for you to get here. Here we go, is F. Got the island right over here. This is both good for defense, but also for trade and accessibility to the mainland. Like Hong Kong would be a case in point of this one. Peninsula site is right here. You've got the sea right here, and you've got piece of land that juts out here, easily defendable. The sea's protecting you, and you'll have one defensible site right here. Bridge point site, BB, right up here. We have a river here and a bridge that crosses here. This is really important for trade, but there's some elements of defense too, because you want to defend that bridge and you want to defend that river, because the river actually can serve as a barrier or a boundary. Let's see. River island site. So here we go. We've got a river right here. Got an island here in the center. Paris is a good example of this, and I'm going to talk about that in a moment. Sheltered harbor site, D, right here. You've got a harbor, and it's sheltered. Good for port, boats, things like that. Excellent, excellent, excellent for trade, but there's also some defensibility capabilities there too. Like Boston would be a classic example of this in New York City. And then finally, confluence site. This would be when two rivers come together, like in this situation right here. In the United States, there's a variety of these, but the classic one would be like Pittsburgh, Pennsylvania, where there's actually three rivers that come together here, close proximity. But this point is both important for trade, but where the city is also important for defense, because then you can control the river going in either direction. So, hope you did well on that. Here's Paris. Paris is a island river site. This is the original Ile de la Cité, the island here, and then the city developed around it. And as it expanded, it built walls and has continued to expand over time. And so originally for defense, but also being on the river has benefits of being for trade also. To better understand site and situation, let's look at the site and situation of New York City. So what we have here is New York City as a specific site of what are the physical characteristics that it's on. The highways indicate its connectivity and its situation, or it's connective to the surrounding areas. So if we look at a 3D area here, we'll get a better sense of the site characteristics that exist inside of New York City. So let's do a little roundabout here with Google Earth. And what we can see is that we have a harbor right here, an entrance from the Atlantic Ocean. We see that Manhattan Island is an island, and this is for defensive purposes. But we can also see the connectivity in the highways and the proximity that it has. The river here is a site factor, but it's also a situation in that it connects New York City to the interior historically. There's also multiple airports here, which would speak to the situation, and you'll see that as if you zoomed in a little bit. But the airports start to appear, and there's multiple airports in New York City, over here to the south, and up here, you can't see it, to the north. But this is a sense of what New York City's site and situation is like. And as we zoom in, we can also see the close-up relationships and the three-dimensional aspects of the tip of the island here, the historical center of where the oldest part of New York City is. And then as we move up into here, the skyscrapers up in this area here in Central Park here, another business district. So New York is unique in this situation that it has a couple of CBDs, but Manhattan itself is a major CBD. And as we zoom back, we can actually start to see that New York City is made up of a huge metropolitan area of system of cities that all interconnect and feed into this area, with suburbs all around in this area and out on Long Island in these areas. All of these are suburbs, with the central business district being New York City here in the center of Manhattan Island. Hey, so let's do an applied case study. Urban geography is really just one subset of economic geography. I mean, you have agricultural geography, economic geography, urban geography, and urban geography's got tons of economics in there. So we have, I mentioned earlier, we're going to talk about baseball, and I'm really missing baseball right now with this COVID thing going on. But, you know, oh well. But we're going to still talk about it. So what we have going on here is we have a map here of shows the different market areas of different Major League Baseball teams around the United States. And if you look at this, this is an economic problem. Like, how many people does it take to actually support a Major League Baseball team? Can you think of a number? Well, the actual number is around 8 million. And we call that a threshold. Now, what threshold is the number of people it takes to support an economic function. And that's going to be a key element of central place theory that I'm going to talk about here in a second. Now, each of these different areas, I'm a big Rockies fan. Here's the areas of the Rockies. This is their market area, because Colorado only has about 3 million, 4 million people. But our market area has to cover a large area because we have smaller population. Whereas if you look at the East Coast, right over here, New York City by itself has 20 million people. So they can support a couple baseball teams. In fact, they do. They have 2 baseball teams. They got the Yankees and the Mets. Approximately split them, it's about 10 million each. Plenty of people to support that team. So this is an applied application of central place theory in economic geography and looking at market area and particular threshold. The other idea of this is this concept of range. Now, range is how far are you willing to travel to engage in an economic function. Now, there are higher order and lower order economic functions. So let's look at this. Let's look at central place theory. So what we have is, this is the center, this is our largest city, and this is where your higher order functions will be, like your Major League Baseball team. Because will you travel a long distance to go to a Major League Baseball game? Of course, you don't do it that often. It's not something you do every day. I guess there's a few people that do. But most of us might go to a couple games, and we'll travel 30, 40, 50, maybe even a couple hundred miles to go to a game. That's a higher order function. Lower order functions would be things like going to get gasoline. Now, you're not going to drive that far to get gasoline. You're probably going to go to your local gas station, your local grocery store, and those are called lower order functions. And there's also medium too. So your largest cities are going to have the higher order functions, and of course they're going to have lower order functions too. Big cities are going to have gas stations just as much as they might have a Major League Baseball team. This here, this area right around here, this is the market area. This is how far, or the range that somebody will travel to engage in that function. So everybody that falls in here with a higher order function, they go into this area here. These smaller area hexagons out in this area, this might be a small town. It might contain a small grocery store and a gas station. But if somebody lives right here, they'll travel to get their gas in this direction. So this is a spatial model of settlements, and it helps us to understand where people are going to go engage in services. As I mentioned before, cities, one of the important functions of cities is services that they provide. So there's some geographic assumptions here. It was written by Castaller in 1930s. You can read about it in the book and blah, 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 blah. But I want to talk a little bit more about this range and threshold of how it works. Because what it does is it allows and creates that urban hierarchy that I explained, where these big cities are then distributed out and spaced out within the urban hierarchy at a national level. So this is going to be applied. Central place theory is applied both at a local scale, but it has application on the national scale of the United States. Here's what it looks like with a flat featureless plane of, say, northern Germany. Big city here, medium-sized city in the center, and then smaller cities on the intermediate. And it creates this distribution that I talked about of spreading out those cities. Now, the world's not a perfectly flat featureless plane. So what happens here? We can have locational biases. This is the Denver area, and the Rockies are over here, as you saw in the video previously. And this creates this distribution of cities, but it still works out. Denver, the largest city, Pueblo down here, Colorado Springs, and smaller cities in the middle. So even with locational biases, central place theory still works. Now, let's talk about transportation. I promise you we talked about transportation. Now, this model is not really something you have to know in terms of the AP test, but I want you to know it. So it's a history of transportation. So in the United States, in the 1800 to 1890s, cities were densely populated. Walkable city was the major mode of transportation. You would walk between these cities and these areas. Now, in 1890 to 1920, streetcars come in. And now what are streetcars going to do to the shape and the size and the form meaning the shape of a city? Well, here's what it's going to do. It's going to create this pinwheel. You're going to have these streetcar suburbs that are going to be along the way, and these streetcars would go into the downtown areas, and then people would walk to the streetcar, get on the streetcar, and ride into the city. And it creates this pinwheel design of a city, of how the land is being used. 1920 to 1950, automobiles, all right, start to come into play. But in 1920 to 1950, not everybody had a car. So relatively wealthy people started to get a car. And if you had a car, where are you going to build your house? Well, in these intermediate areas right here. So these are those inner suburbs. And we're starting to see the landform of the city. But what's key here is how transportation is forming this. And then finally, 1950 to the present. Now, the car made the density more moderate because we could spread out. These areas are still pretty compact and dense. What do we think is going to happen when the freeways and the modern, everybody after 1950, pretty much everybody gets a car in the United States? And here's what happens. The city size explodes. The density goes down, but the size of the city expands. And it follows these routes of where the highways went, the beltways, the interstates, and this is the directions in which the city is going to be flowing. Now, understanding modes of transportation is not just an urban geography thing. We need to also understand in economic geography and agricultural geography how products move back and forth through our system. And highways is an important element of that and has influence, hence the beltways, by being able to bypass major cities and connecting into markets, because this is where people are going to need food. It's where you're going to need goods and economic functions. And so transportation is a key element to understand, and knowing these rough dates will help you in other units besides just urban. So make sure you pay attention to that. There's a guy called Borchart's Transportation Epochs, and notice it stops in 1967. But there's a couple big things that he talks about. There's 5 periods here. The sail wagon epoch, 1790 to 1830. That's the high density. That's the walkable cities that I talked about. Iron horse. This is trains, 1830 to 1870. This is the steam engine. Now, this helps. This influences the distribution of cities, because small towns would go along where the trains would stop along the way, because they have to have coal and they had to have steam and had to stop more often. This is when those small towns right outside major cities would exist, and it started to spread the distribution of cities. But industry in economic geography would oftentimes follow where the railroads go. So it's a land use issue also. And factories would often locate along the railroad lines, or the railroad lines would go to the factories. It could go either way. Now, steel rail, 1870 to 1920. This is the development of long-haul railroads. So what starts to happen here is that trains can now go a much further distance. They don't need to stop as often. And because they don't need to stop as often, some of those smaller towns in the intermediate areas start to get cut out. And the train doesn't stop there, so it hurts their growth. And so the distances between cities start to expand. Now, in some of our East Coast cities, those iron horse lines now have become commuter rail lines, and they bring people into the cities. With the long haul airlines transporting goods, mostly goods in the United States and freight, but sometimes people on like Amtrak and things like that. The United States has an exceptionally developed freight rail system and is extensively used. 1920 to 1970, this is the auto air amenity epoch. And what happens here is the growth of the combustion engine, interstate highways, air travel. This is the expansion of cars. So in automobiles, and it has two phases as explained before, state highways, and then post-World War II would be the extension of the interstate highways, and the impacts of where cities go. And where those interstates went really, really influenced the distribution of cities. Now, finally, this one is the satellite electronic jet propulsion, 1970 to question mark. Now, notice he wrote this in 1967, so he didn't really write about the major jet airliners. Other researchers have extended this. But today, we talk about major airports, the interconnectedness that exists between our cities and how we transport through jet engines and internationally and domestically is the key transportation technique. And in today's modern world, if you don't have a good airport, your city gets skipped. And it really hurts the development and economic growth of those cities. So here's just a visual representation of those just to help you. Nothing special, but it gives you a sense of that, of the epics that we've been talking about.